get indeterminate form, you might want to try manipulating your equation, or your expression, I should say. Okay? For example, the limit as x tends to 2 of x squared plus 2x minus 8 all over x minus 2. Can I evaluate that algebraically by just plugging 2 in? Check out the denominator.
Oh, no.
The denominator is going to be 0. That's a problem. That's a big problem.
So we can factor and reduce.
Yeah, maybe we can factor and reduce. There's a hope of factoring, isn't there? Because we have a polynomial involved. So does x squared plus 2x minus 8 factor?
The top one, right? Yeah.
Yeah, the top one. Is the top expression factor? Okay. The limit as x tends to 2 of x plus 4 times x minus 2 all over x minus 2. Now I'm going to be picky. Yes, I want you to write the limit as x tends to 2 in front of every single step that you're taking the limit. Where you have not yet plugged in 2, you have not yet evaluated the limit, you need to tell me you're still taking the limit. You haven't done that yet. Okay? Oh, the x minus 2's now reduce away, and that's kind of the magic step, is what I would call that. That's why this works. That's where this helps you. We'll talk about what you just found here in a minute after we do another example as well to get this under your belt. Okay? The limit as x approaches 2 then of x plus 4. Guys, this is the same function as the one I had to begin with, except at x equals 2, there's a slight difference, but the limit values will be the same. Okay? So how can I evaluate the limit as x tends to 2 of x plus 4?
Plug 2 for x, maybe it's 6.
Plug in 2 for x. So now we are evaluating the limit, so I will drop the limit notation at the beginning and just say that this is 2 plus 4, which is 6, as you said. So that limit as x tends to 2 of my original function equals 6. Little manipulation there. All right, we're going to try another one before I talk about what you just found. The limit as x tends to 2, again, that's coincidental, but we'll go with it, of x minus 2 on the top this time, over x cubed minus 2x squared plus 2x minus 4.
That was a big leap from...
I was going to say, I'm impressed. I didn't hear any groaning. As soon as I started writing x cubed, I thought people would start going, Rockney, can you go to the verse?
Is that a real question, or are you just wanting to leave?
Yeah,
You're
one
all
more
right?
my head's on
Okay. All right. Here we go.
Take an x out from the denominator?
You're all right. So, how can we factor the cubic in the denominator?
Take an x out, nope.
Take an x out. You can take an x out of 3 of them. I can't take an x really out of the 4th one. At least it doesn't get me anywhere good.
Nope.
So I can't, there's nothing I can factor out of all of them. I can take a 2 out of the last 3, but that doesn't get me anywhere either.
Do you have a 0 on the top?
You can have a 0 on the top, but this also caused you to have 0 in the denominator. We should check that, shouldn't we? So if I plug 2 in here, I get 8 minus 2 times 2 squared. 2 squared is 4 times 2 gives me 8. So 8 minus 8 is 0. Plus 4 minus 4 is still 0. So
That's no fun.
yeah,
I was like, oh.
I still get indeterminate form. You can have 0 in the top to answer your question. All right. So we might try factoring. Yeah, maybe. Huh? Yeah. Grouping and factoring is a good way to factor something that has an even number of terms. Good way to try factoring something that has an even number of terms. We did that way back at the beginning of the year, maybe chapter 2, something like that. Okay. So the limit as x approaches 2 of x minus 2 over factor what out of the first 2 terms?
X.
factor,
2x?
yeah, an x squared. Factor an x squared and you get x minus 2. And then what can you factor out of the second two pairs?
2.
2. So I'm going to put a plus 2 times the quantity x minus 2. Be very careful. If you factor out a negative right here, just like for hyperbolas, you factor out a negative right here, you're going to have to change the sign of both of these. Okay? And it's tempting to forget to change the sign of the second one.
It's like you can't
But
get
we
rid of
didn't
the
do
x minus 2, right? Because they're still like paired with other things.
Oh, but now there's an x minus 2 in common with both of these two things that are added together.
Mm-hmm.
So I can take that out of both of the things that are added together.
So
Does that make sense? You can factor out an x minus 2 from both of these two things that are added.
okay.
Okay? So this is like the limit as x approaches 2 of x minus 2 over what? Good. X squared plus 2, the quantity, times x minus 2.
So now can you
And
cancel?
now you can reduce. Yes, now you can cancel the x minus 2's all at the same time. It's not like you're canceling the x's.
Then we just have
separate.
1 over, right?
So then you get 1 over. Very good. I've seen lots of creative things. When the numerator goes completely away, people go, oh, now I just have x squared plus 2. No, no, no. The denominator doesn't get to move up to the lots of creative people in math. I understand. But make sure you're mathematically right. Okay? So the numerator leaves you with 1. The denominator is now x squared plus 2.
You get 1 over 6.
Ah, so 1 over 6.
See, I like
Nice
this kind
work.
of stuff.
So this is equal to, again, I'm going to drop the limit notation because I'm now evaluating the limit. I'm plugging the number in. So I'm plugging into for x, and I get 1 over 2 squared plus 2, which is 1/6. Okay? Now before we go on, I want to go back to this one over here. Do you have questions over how to do this? Factoring can be difficult, I understand that, but recognizing that you can factor and that it can help you evaluate the limit is part of the battle. Okay, a big part of the battle. What did we find? Well, over here I'm going to graph the original function for you. Okay, you can do this using a graphing calculator if you wanted. You could make a table of values, but I'm going to do it quickly for you. And then we're going to talk about how these two functions are different and why you can use this function down here, x plus 4, to evaluate the limit of the original one. Because the original one definitely doesn't exist at x equals 2. But what kind of discontinuity does it have? Okay, so here we go. Here's the original function. At x equals 2, it has a hole. It doesn't have an asymptote as that hole. Okay? The function that you just used down here, x plus 4, is exactly the same as this function, except it doesn't have a hole. It's just overlapping that function right there. It fixes the hole. Okay? A hole is what we call removable discontinuity. It can be fixed. It's not like an asymptote. An asymptote that's just not going to be fixed. Okay, and we talked about Wednesday in here. Holes, can you evaluate the limit as x approaches an x value where there's a hole? Like, what's the limit right there? Yeah, I can't really tell, but does it exist?
Yes.
Okay, it's actually at a height of 6. What the function looks like it is approaching is 6. Whether there's an actual hole at that value or not is irrelevant. The fact that you are pointing toward the height of 6 is what matters. Okay? And this function approaches the same values everywhere as the original. It just does not have the same value at the limit value at x equals 2. But that's irrelevant. You're not interested in what your function actually is all the time. So, what you did is you fixed the hole. It's not like an asymptote where your limit approaches infinity. It's not like it's not one of the cases where your limit does not exist. When does your limit doesn't exist? If you have one of the three things we defined yesterday or Wednesday in here. When you have like oscillating behavior, where you get that, like we said, yeah, you're all making fun of me for. You have the oscillating behavior when you have the limit approaching two different things, or when you have an asymptote. That's not what you have here. Okay, so the limit exists. The question is, what is the limit? And we reduced in order to find out what that is. Did you get it?
Yeah,
All right,
they're all
the
over.
wily fly. What questions do you have? You don't need the graph to do this problem, either one of these problems. You can do them without the graph, okay? You can do them algebraically. You just have to be able to manipulate the function to a place where you can plug the value in, because you can't do it from the beginning, okay? I'm going to erase these. Is that okay?
Mm-hmm.
Any objections?
Go for it.
The ayes have it. How about this one? The limit as x approaches 0 of the square root of x plus 9 minus 3 all over x.
You can't have 0 in
You
there.
can't have 0 in the denominator.
Could you?
There's a lot of creative things I've seen people suggest here. What are you thinking? Evaluate numerically wouldn't be a bad idea. But let's try to evaluate this thing algebraically. You can do it.
And
Yeah, it's going to take some manipulating, but yeah, you can do it. So, how?
Remember what you
where
do
we
is
have
stupid.
to-
No, because if you square the top and the bottom, you still get 0 on the bottom.
Okay, and you can't just go squaring fractions. 2/3 is not the same thing as 4/9.
Oh.
But you can do some things to fractions and not change the value. What can you do to a fraction and not change the value? What can you do to anything and not change the value? Add what? What doesn't move me? If I'm on x equals, if I'm on the value of 2 on the number line, what would not move me? Add 0, subtract 0. What else can I do?
Multiply by 1.
Multiply by 1. We're going to use the multiply by 1 here.
Maybe.
Okay, so how do I multiply a fraction by 1? Strategically, sometimes you,
1 over 1? Right?
yeah, put 1 over 1 and maybe make them not 1.
Multiply by x.
Multiply it by, you can't just multiply by x, but we could multiply by x over x. We could multiply by the same thing on the top and the bottom, and that is multiplying by 1. Okay, so now the question is, what do we multiply by on the top and the bottom? We're going to multiply this fraction on the top and the bottom by something to help me fix the problem. The question I have is now, what's the real problem here?
X is 0.
X is 0 in the denominator, but Ben suggested a minute ago about distributing that square root. I'm not trying to pick on you, but what were you trying to get to happen when you did that? You maybe saw the 9 square rooted gives me 3, and then wanted the 3's to cancel out, but then what happens if that were to be the case?
That'd be 0, 0.
Okay,
But that doesn't work. So
but you still, but having the square root of x over x is not the same issue as having square root of x plus 9 minus 3 over x. If I had only x's, that might be a little bit nicer because then x's can reduce. So perhaps there's something that will allow me to free the x out of the square root. I can't just square it. I know, you want to. This one. Yeah, you might be going, what's the conjugate?
That's
I
what I
don't
was
know what that
thinking.
is. Well, to multiply by the conjugate, you multiply top and bottom by the same thing. First of all, we said that a minute ago,
Okay.
because you have to multiply by 1. We're going to multiply by, instead of the square root of x plus 9 minus 3, we're going to go the square root of x plus 9 plus 3. That's the conjugate. Do you remember that?
It's like the opposite.
Yeah, you change the sign in the middle.
Okay.
Okay? We'll talk talk about how it multiplies together here in a minute. And we're going to do that on the top and the bottom. You always want to multiply the fraction top and bottom by the same thing. If you don't, you change the fraction. Okay? Now my question is, how in the world do I multiply the numerators together? Probably should put some parentheses. What am I going to have to do?
Can we plug in 0 yet? Or no?
Not yet. Still have 0 in the denominator. How can you multiply the numerators together? Probably are going to have to do something that starts with an F.
Foil?
Yep.
Ew.
It doesn't turn out as bad as you might think.
I'm like looking at it, I'm like, square x plus 9
Thanks for
squared.
being honest. So first, and I still have to write the limit notation, right? Now this one, you might want to get some mumble space going because you might want to like, yeah, because you don't want, maybe you don't want to rewrite this entire expression every time. Maybe you want to multiply just the two things on the top together and find out what they come out to be simplified.
Okay.
Without writing the entire thing, denominator included, limit included,
Right.
every time. So you can do that. You can get some scrap paper out and evaluate the top. Okay, foil the top together and simplify if you want to do that. However, let's work through it together here real quick. Limit as x approaches 0 of first multiplied together. What's the square root of x plus 9 times itself?
Does it get rid of this right now?
It does. It gets
Yay.
rid of the square root. So you get
X plus 9.
x plus 9. Outsides. So the square root of x plus 9 times 3. What's the square root of x plus 9 times 3?
3 times x plus 9?
3 times the square root of x plus 9. Very good. 3 times the square root of x plus 9. Insides. Negative 3 times the square root of x plus 9 becomes,
And then negative 9.
hang on,
Oh, sorry.
negative 3 times the square root of x plus 9.
Then
And then negative 3 times positive 3 gives me negative 9. That's the numerator. And yes, we'll simplify it here in a second. I would not recommend you multiply the denominators together until you absolutely need to, and you'll see why in a second.
So just
Okay? So don't multiply the denominators, don't simplify the denominator yet.
add x times the quantity x plus 9 plus 3.
Exactly. Okay? What happens in the top?
The 9's cancel.
No.
And I almost want to say like the square root, like they both have like the opposite and they're both the same. Can you cancel those?
Yes, you can.
Okay.
If you have plus 3 of something and minus 3 of the same something, can you cancel them?
Yeah.
Those make 0, right? Okay, so what are you left with in the numerator? So you actually have the limit as x approaches 0 of x over x times the quantity, the square root of x plus 9 plus 3. Why don't you want to multiply the denominators together?
Can you get rid of the x on the outside? Yeah? Okay. I didn't know if it was times by something.
Yeah, that's the reason you can. If it were added to something, you couldn't. But
Okay.
because it's multiplied, not added, you can cancel it, you can reduce.
Okay.
Like reducing a common factor.
Mm-hmm.
Okay? So the x cancels out, and that's the magic. Right there. That's what fixes this problem, because now you have or that's what has a chance of fixing this problem, I should say. Because now you have the limit as x tends to 0 of what?
Are we plugging 0 in or not?
Not
Or
yet.
just 1 over square root of x plus 9 plus 3.
Okay.
And then when you plug it in,
Now we can maybe plug it in. Can we plug it in?
yes,
What do we get?
1 over 6,
1 over 6.
right? Yeah.
So 0 plus 9 gives me 9. Square rooted gives me 3. So 3 plus 3 gives me 6 in the denominator. So 1/6 is what this limit turns out to be. Read your Wheaties this morning.
I had coffee and like fruit.
I had Special K.
What
kind?
All right.
Like, I don't know, strawberry.
Oh, I love that
What
guy.
do you think?
I like this stuff a lot. I understand it.
A very mathematically manipulative person.
Huh.
Love it.
Only not five.
Oh, yeah.
Mathematically.
Only.
We're gonna say that right now. All right. So multiplying by the conjugate, conjugates always have middle terms that cancel out when you FOIL them. The outer and inner terms will always cancel out like this. That's why you don't end up with a square root, because you have the original first term squared and the original second term squared. So square roots squared will go away. So this frees your x from being inside the square root and allows you to cancel the x's or reduce the x's and get rid of the x in the denominator. This is not going to go away. Multiplying top and bottom by the conjugate is going to pop up a lot in the next 6 months, maybe taking away June, July, and August. But next year, oh yeah, it's coming back. Maybe even later here this year too. Well, yeah, definitely later this year. All right, but it's coming back next year. So keep that in mind. Throw that in your math nerd bag of tricks.
I'll be so good at calculus.
Multiplying top and bottom by the conjugate is definitely something you want to keep at the ready as a trick to employ to manipulate a function.
When you take the conjugate, that's just the top one. Do you always do the top?
It's always the one. It's always the one that's a binomial.
Okay.
So it's always the one that has two things. Sometimes it's the top, sometimes it's the bottom. But in
Okay.
this case, it was the top. It won't always be. What other questions do you have? I want to let you try these, because every problem is going to be a little bit different. Notice I didn't put numbers on those things over there. It's not like you can employ the first one, second one, and the third one in that step. It's not a step-by-step process. It's, I can't do this problem right away. I can't just plug in the number. Now what do I do? And you have to use the tools that you have in your tool bag. Okay? All right.